All right, let's really fast talk about the three methods of heat transfer. Most of this should be review for you. You probably had this in about the 8th grade, and understand if you don't remember. There's another video on this on the same videos page. If you go and look at that, that will explain a little bit more, perhaps a little bit differently than the way I'm going to explain it, but this is going to be pretty quick stuff. So the first and probably simplest method of heat transfer is called conduction. Conduction is heat transfer by direct contact. So anytime two objects are touching each other in direct contact, they can transfer heat. Obviously, heat will go from the hotter object to the colder object. It doesn't necessarily have to be two objects. It could be something like this example that you see down here. This is, for instance, like if you are cooking something on a stove and you have a pan that has a metal handle. That metal handle will begin to get warmer, perhaps not as hot as the part on the bottom, but it'll begin to get warmer because all of the molecules in the pan are in direct contact with each other. So that's one example. Another one would be if you put your hand on a stove, obviously it burns because it's in direct contact. If you put your warm hand on a cool desk for a few seconds and lift it up, you might find that there's an imprint of your hand there. That's because heat was transferred to the desk. And then in class, we did the example of melting ice on a piece of metal. In that case, heat is transferred to the ice by conduction, by direct contact. So conduction is heat transfer by direct contact. The next one is called convection. Convection is heat transfer. Now realize, with all of these heat transfer methods, the direction heat transfers is always the same. It's always from a warmer object to a cooler object, from hot to cold. But this is heat transfer specifically by the flow of a fluid. And in this case, we mean a liquid or a gas, just anything that can flow, liquids or gases in this case. So examples of this would be the wind. When the weatherman says that the winds are going to shift around from the south, the temperature is about to rise because we're getting warm air from the Gulf. That is heat transferred directly by the flow of a fluid. We're going to take it from the Gulf and move it up north where we are. A wood stove in the corner of a room. What happens is the stove will warm up the air around it. Let's say this is the corner of the room. Imagine that. Ooh, how about a pen? Ooh, how about a red pen? Yeah. So here's a wood stove. Where's my red pen? There we go. Wood stove in the corner of the room. And it heats up the air surrounding the stove. That warm air will rise. Imagine this whole slide is a room. As it rises, it actually gets replaced by... Give me a blue. Purple is good enough. It gets replaced by cooler air coming in from the bottom of the room, okay? And that air needs somewhere to go. So there's air up here that replaces it, and then the warmer air that rose earlier will come in here and replace this air over here. And what happens is we get this convection current that gets set up in the room. And after a while, the heat from this stove will actually fill the whole room. So the wood stove can heat the entire room. We're talking about, you can, let's see, erase all ink. That works. Another one is a hairdryer. Obviously, transferring heat by the flow of a fluid, which is air in that case. And then there's one that's not in your notes, but this is actually the most important example of convection to you. That's the blood in your body. If you take your hand and put it up to your face, you'll feel that your hand is warm. And if it's not, if your hand is cool to the touch, that means you may not have wonderful circulation. If your hand is cool, that's actually proof of the fact that heat is not produced in your hand very much, not very much at all. The majority of the heat in your body is produced in your core, in your torso, and it gets to your extremities, to your hands and your feet, by your blood. Your blood transfers warm. Your heart transfers warm blood out there to your hands, and that's what causes your hands to be warm. And this is a really, really important physiological adaptation for many, many animals that don't have the blessing of climate control like we do. Like we have the mind. We had the mind to invent. And so they will use blood to either get rid of heat. They'll shunt blood to certain places to get rid of it, or they will stop blood flow to certain places to prevent heat loss. Important to understand that this convection is the most efficient method of heat transfer. It's most efficient to just take heat from one place and move it to another place. So here's some more examples, pictures of convection. We saw the radiator earlier. There's the picture of the convection currents in the room. Same thing happens if you're cooking water on a stove. The third and final method of heat transfer is called radiation. Now, before we write this down, many people, when they hear the word radiation, they think bad stuff like nuclear radiation, the Hulk, Chernobyl, cancer treatments, radiation cancer treatments. Those things are not what we're talking about here. That is harmful radiation, and it's in the same ballpark, but we're not talking about the same thing. This is not harmful radiation. So radiation heat transfer is by electromagnetic waves, which is specifically infrared radiation. This is basically just light, and a lot of people don't understand that. You'll understand it more when we get to light, when we talk about light in this class. But it is light that your eyes simply cannot see. It's at a frequency below what your eyes are sensitive to. Important that you know that radiation is the only one that works in a vacuum. And the way that we know that is the first example of radiation is the sun. The sun's energy reaches us through the vacuum of space. There is nothing out there. The sun's energy doesn't reach us through convection. There's no fluid flowing towards us. And thank goodness the sun's energy doesn't reach us by conduction. It's not touching us. The sun's radiation can go through a vacuum. Now, it doesn't have to go through a vacuum. There's radiation happening right now. Your body, since you're warm, you are radiating heat. You are sending out infrared radiation in all different directions. And you're doing it through air. You can do it through water. It can go through many different substances. It doesn't have to go through a vacuum, but it can. And it's the only one that can. If you warm yourself by a fire, imagine that, give me my pen again. If you imagine that there's a fire right here, if you put your hand on top of it and feel the heat, that's actually convection because the fire is heating up the air and the air is flowing upward. But if I put my hand right here beside it, I feel the heat because of radiation. And the reason is because that fire is radiating infrared radiation. It's sending out infrared radiation, which we feel as heat in all different directions. On a warm day, you might huddle together, or sorry, on a cold day, you might huddle together with people so that you can warm yourself by your body heat that's radiating from your bodies. And I want to emphasize this is not dangerous stuff. Unless it's too hot, it might burn you, but it doesn't have enough energy to mess with your DNA. It doesn't penetrate your skin. So it's not the dangerous kind of radiation. It's non-ionizing radiation. And last thing I'll say is microwaves, that's not an example of heat transfer by radiation. Many people will think of that when I ask for a radiation heat transfer example. A microwave is not an example because there's no heat being transferred there. This is all heat being transferred from one place to another by radiation. If you think about a microwave doesn't transfer heat. It actually induces heat. And we'll talk about that mechanism another time, actually when we get to sound. It's called resonance. But the microwave itself doesn't get hot when you're cooking food. And that's a clue that it's not heat transfer. It's that it's inducing heat somewhere else. So point being, a microwave is not an example of radiative heat transfer. Those are the three examples, three methods of heat transfer.